are graphing log functions, what we are going to keep in mind is that the log functions and exponential functions are inverses. So think about everything that we've been doing with inverses lately, right? That means that their graphs are going to be reflections over what line? What's our, yeah, y equals x, good. So they're going to be reflections of each other over the line y equals x. So guess what? We are going to be graphing that. Remember that when you find an inverse, it says blank and blank are switched. What are the blanks? Yeah, the x values and the y values. Now, keep in mind that the x values are also related to the what? Yes, the domain. Good. And the y values are related to the range. Okay, so those are going to flip as well. Now, speaking of domain and range, we talked the other day about things you have to look out for. And we came up with fractions, and we came up with square roots because there's an error there. Now, we have to keep something else in mind. So we're going to write a special note. You cannot take the log of, There's going to be two things that you can't take the log of, okay? One of them is going to be 0. Okay, the other thing is going to be a negative number. So you can't take the log of 0 or negatives. So is that going to impact the domain or the range? Does that have to do with what you plug in or what you get out? Well, which one do we have to watch out for? The inputs or the outputs? Yeah, the input, right? Okay, now let's talk about why that happens. I'm just going to use the base of 10. Okay, if I could take the log of 0, that means 10 to some power would equal 0. So what is 10 to the 0? 1. So that wouldn't work. What happens when I plug in negative numbers? I get a fraction. Okay, so there's nothing I can plug in for x that's going to give me 0. Okay, that is unsolvable. It's the same thing if you were to get a negative number. For example, if I had 10 to the x equals negative 10, I know we'd really, really kind of want to put in that negative 1, but what is 10 to the negative 1? Yeah, 1 over 10, right? It's a fraction. So that's not going to work either. So those have to, that's going to be taken into account when we're talking about the domain. Now, in example 4, part A, we are going to be using our calculator for this, and that's because you have a decimal. There are some graphs where you can use a calculator. There are other ones that you don't have to use your calculator for. We'll go over a little bit of each. And this says that we have to use the given x values to graph the function. Okay? Then we are going to graph its inverse. Anytime it tells you to graph an inverse, a little light bulb should go off that says, oh, if I'm graphing the inverse, what else do I have to include? Yes, you have to include the line of reflection. Okay, which is y equals x. And then we're also going to describe the domain and the range of each function. Okay? In fact, if we wanted to, we could even put in the line of reflection right now. Because if it's y equals x, it's always just going to be this diagonal going right through the origin. Okay, and then we are going to be graphing that. Now, they give you your f of x. Okay, f of x equals 1.25 to the x power. Okay, that's your f of x. your inverse is going to follow a special pattern. So I'm actually going to give you some examples, okay? If your f of x, and you don't have to write this down, I'm just going to show you so we understand what's happening. If your f of x is 2 to the x power, your f inverse is just going to have the same base. What's my base? 2, so it's log base 2 of x. You always keep x as your input. So let's say I had f of x equals 5 to the x power. What would my inverse be? Log base 5 of x. Okay, so in this case, what is my base? Yep, so then this is going to be, your inverse is going to be log base 1.25 of x. Okay, so f of x and f inverse have the same base. Alright, so you are able to write that just from this alone. Again, this is a subscript here, this is lower, everything else is on the same line. This is not an exponent. Okay, so for your table, they told you what values for x you're going to use, so you are going to use these as your x values, -2, -1, 0, 1, and 2. And then, because this is a decimal, I'm going to let you use your graphing calculator, even though technically we could turn that into a fraction, but don't worry, we're not. Okay, so this is exactly what we did on Monday. Okay, what we did is we graphed, right, 1.25 to the x power. We created a table. You might have to go back to your table set and go by ones. It just depends. Okay, so at -2, I'm at 0.64. At -1, I'm at 0.8. And this makes sense because anything to the 0 power is 1, right? Anything to the first power is that same thing. And then I have 1.5625. Okay, any questions for me on filling out your table there? So your f of x. So this is your table for f of x. So it's the 1.25 to the x. Yep, so that's what we're going to plug in. Okay? And also, when you're doing your homework, you need to do this like we're doing on our notes. So like with the graph, if you want your points for your homework, you have to show me like what your table is and that you're graphing specific points. Okay? And the reason why I say that is because some people just graphed on their calculator and didn't even label like the x and y axis. That could be a graph of anything. You have to make sure that you're labeling those. Okay, so that will go for tonight's as well. Alright, now, when you're doing the table for the inverse, remember, with the inverse, what happens with your values? Yeah, you just switch the x and y. Okay, so that's all we're going to do. You don't have to plug that in your calculator. In fact, it would take longer if you did. Plus, you don't know how to enter that in your calculator yet, so you're not going to do it that way. Okay, so we're just going to flip the x and the y's. Okay, and then we are going to look at the graph. You can go to Zoom, go to your standard window, so we can remember what's happening here, okay? This graph is approaching what? Yeah, the x-axis. Do you guys remember what we call that line? Yeah, the asymptote. And then this is going to be the line of y equals 0. So when you're doing your domain and your range, okay, the domain is for your f of x. Remember, f of x equals 1.25 to the x power. This is exponential, okay? When you're talking about the domain, you're just looking to see, hey, Is there a fraction? No. Is there a square root? No. Is there a log? No. So if not, then your domain is just what? All real numbers. And again, from Monday, that is all that we did. From section 4.1, okay, all of your domains for that was all real numbers. Now the range has to do with the asymptote. So if it's approaching the x-axis, what would we say for the range? Yeah, what's greater than 0? Yep, great. Y is greater than 0. Awesome. Okay, and then remember, for the inverse, just like the x and the y switch, the domain and range switch. So for log base 1.25 of x, okay, your range from the f of x is now your domain, which we just talked about this, right? So if this is x is greater than 0, does this fit in what we just talked about? That you can't take the log of 0 or negatives? Yeah, that fits in, right? X has to be greater than 0. It does not include 0. And then the range is going to be what? If they switch, what's it going to be? Those are all real numbers. Do you remember how for exponential functions, it's following the x-axis? Guess what's going to happen with the logs? Everything switches. So what's it going to follow now? If this one follows the x-axis, the other one's going to follow what? Yep, the y-axis. Okay? Now, when you look at these points, okay, we have very small numbers here, and they've told us that these are the values for x that they wanted us to do. So if they give us these small values for x, we need to make life a little bit easier for ourselves, and we need to give ourselves a scale to make plotting these points easier. Okay, so we're gonna use a very small scale, and then just understand that you're getting a snapshot of part of that graph. So because I have like 1.25, this is close to 1.5, the 1, I'm going to make my scale go by quarters, so 0.25. So this would be 0.25, this is 0.5, 0.75, 1. This would be 1.25, 1.5, 1.75, 2. Because again, I want to make this easy on myself to graph. So this is negative 1/2, 0.75, negative 1, negative 1.25, negative 1.5, negative 2. Okay, and then remember, the x and the y switch. So for ones like this, it is good to use the same scale on both. Okay, so 0.25, 0.5, 0.75. This would be 1, 1.25, 1.5, 1.75, 2. So it would be negative 0.5, negative 0.75, negative 1, negative 1.5. Okay, so that's going to make it a little bit easier for me to graph that. Okay? All right, so for the first one, I have negative 2.64. So here's 0.5, this is 0.75. It's going to be somewhere in between those two. At negative 1, I'm at 0.8. So this is 0.75. It's going to be pretty close to that. At 0, I'm at 1. At 1, I'm at 1.25. Okay, and I know this one is going to seem a little different, but it is going to be on the other side of this line. So here's 1.5, so it's going to be really close to that. And then remember, when you connect your points, you're connecting them with a what? Yes, a slight curve. Good. Yeah, we did these the straight edges yesterday. For exponential, it is going to be a slight curve. And so I'm just going to show that that's going to continue going up. And again, we're just doing a snapshot of part of our graph here, right? Of part of this graph. Okay, so that does look a little bit flatter because we don't have all those points on there. But they give us the x values, so that's what we're doing. Okay, and then this one is 0.64, -2, 0.8, -1, 1, 0, 1.25, 1, and then 1.56, -2. Okay, and again, we're connecting that with a curve, slight curve here. And look, we can see that this is a reflection. Doesn't that look nice? And a nice reflection there. You have your inverse and you have f of x, and they're reflections over each other.